I haven't recorded this one. This is a new one I found for this year. I know, right? Even though I'm old, I can still learn new tricks. Nice, right? Good try. I haven't been 25 in quite a long time. Okay. All right. Let's talk about John. Let's talk about John. Okay. John. Okay. So John is that guy, I guess, that goes on a walk and wants to like measure stuff about his walk. All right. I don't know. Those people exist, I guess. Anyway, so John has recorded 7 different speeds on a walk and checked at that moment the pulse rate of his body, okay, for his heart. All right. And we are given a scatter plot. So when you're given a scatter plot, go ahead and take a moment, right, and make sure you know that this is the explanatory variable, or the x, and this one is the response, or y variable. So you don't have to like write this, but in my brain I'm thinking John thinks that his speed explains his pulse rate. That's what he did by setting up this scatter plot. John's speed explains his pulse rate. Okay? Now, they also printed a bunch of computer output. All right, and I've told you guys, since the first semester, you got to be able to read a lot of this stuff. Okay? So in part A, it says, using this output, which has a lot going on here, what is the equation of the regression line? So I'm going to start by highlighting where it says constant. All right? The coefficient next to it is called the y-intercept. Very good, Julia. Well done. Say it one more time. They're telling you it's the one that doesn't have the variable. That's what constant means. So that's why they say constant. But yeah, sometimes the AP exam will write intercept here to make it a little easier. Okay? Now, if I highlight speed, right, this is our x variable. Do you remember what this coefficient is called? The slope. So I'm going to put plus 16.2809. Hopefully to make this easier, all right, that slope that I highlighted in yellow, what is the word that is before that highlighted in yellow part? Speed. So make sure you put parentheses, speed. Could you put x there? Yes, you could, but then you would later have to say x is equal to speed. So I'm trying to save you time. Just put speed there. So the very last thing to do is to say what this is equal to. And it's always equal to the y variable. But don't forget, I am going to write pulse like Georgie said, but what has to be on top of the pulse? A hat. This means it's predicted. So if I were to say, I wonder what John's heart rate is if his speed is 3 miles per hour, right? He's walking at that pace. I could plug in 3 miles per hour, and it would give me a predicted pulse for his heart. All right? Pulse. All right? So that's why I put the hat. It's predicted. Are there any questions about this? This is not new. This is first semester, chapter 8 stuff. All right? So if you forgot this, we're reviewing it now. We'll also review closer to the AP exam. All right. Flip it over. Do your estimates of the slope and y-intercept have meaningful interpretations in the context of this question? If they do, provide the interpretations in this context. If not, explain why not. All right, so let's start with the y-intercept. The y-intercept is, I think it was, I already forgot, 63.457. All right, so I'm just telling the AP reader, this is the y-intercept. Okay, now in algebra, you guys learned, probably even in middle school or early high school, that the y-intercept means that if you plug in 0, for x, then you get the y-intercept, right? Because if I plug in 0, then all this is gone. My y would just be the y-intercept. So in this case, I'm saying if John is walking at a pace of 0 miles per hour, what do I expect his pulse rate to be? So I'm going to write that down. Well, give me a second, man. I mean, spoilers, right? Camilla and Angel may not know. Okay. If John, my bad. Gotcha. If John walks at a speed of 0 miles per hour, then I expect his pulse rate to be 63.457 beats per minute. 457. Will his resting heart rate be that all the time? Probably not, right? We would need to find an average here, right? So that's why I put like expect, because it's not going to be exactly that. All right. And David, I heard you say, right, this is what I expect his resting heart rate to be. Or we're talking about zero speed, right? Zero speed. And I would argue, I mean, I'm not going to argue this, but David would, right? Do you have a different resting heart rate when you're standing as opposed to sitting? Yes. Okay, so like I'm not getting into the nitty gritty here, but that's probably different. Okay, let's do the slope. The slope is 16.2809. The slope is 16.2809. So let me go back to how I did this in the first semester. Okay? Slope, what I try to teach you guys, is that if you increase your x value by 1 unit, then I expect the y value to change by the slope. I'm going to say it again. Okay? If I increase the x by 1 unit, I expect the y to change by the slope. Notice I didn't say like go up or down, because that depends on the sign of the slope. Okay? So if John walks 1 mile per hour faster, what do I expect to happen to his pulse rate? To go up by about 16.2809 beats per minute. So I'm going to write that down. 8675309. 8675309. That song?
No, it's
no? Tommy Two-Tone?
No, it's like the floor company? Yeah, like the floor company. No.
Well, it's different, right? In different cities. Like it was different in Chicago and other things. If John walks 1 mile per hour faster, I expect his pulse to increase by 16.2809. I don't know what you did, but I tried. Beats per minute. Thank you, Julia. Pity laugh.
Yeah, I was gonna say that's like a large amount. Like you're just walking 1 mile per hour. Actually,
I don't know. Why don't you get some data?
it's not physics. Nate runs.
Yeah, ask Nate to do it for you. That works too. But that's running, so that's a little different. Right, this is walking.
Wait, how much is like
How do you walk?
how much is fast?
I don't know. Like, what are you saying? Like on the treadmill, what's?
How fast are you going on the jog?
Well, it depends on the person, right? I bet Nate's jog is different than my jog, right?
Yeah, but
Yes, and I'm old. There's usually, at least in my experience, I don't really run on the treadmill, but when I have, it's like when you get to a certain setting, like, okay, now it's like uncomfortable to walk, like I might hurt myself, so I need to start jogging. So I'm sure everybody has that. It's probably just different for everybody. Well, it's like, you're going so fast, right, that you might as well start actually jogging.
Those reasons to me are so funny, the speed walking reasons.
Right? Right? It's pretty good. It's like how the upper body doesn't move. It's impressive. If only Angel and Camilla could have seen that, right? They missed out. Okay. Thank you so much. I'm 25 and I'm impressive. What a day. Okay. Part C. This is the first part that is now new. All right? You can see it's not really new, but like this is the new stuff for this unit. Okay? So far what we've done is not new. This is like so last semester. Okay? So here we go. It says that John wants to provide a 98% confidence interval for the slope parameter. All right? So they'll always tell you what they're running the confidence interval for. I told you guys that we always are running a confidence interval for a population parameter. In this case, for the slope. So my first thought is I'm going to make sure that when I'm looking at this, I'm looking at the slope. All right? So here's what the AP exam is going to give you on the formula sheet. To run a confidence interval, it is statistic plus or minus critical value times, and I'm going to make this a little easier for you. They write standard deviation, but I'm just going to tell you like 99% of the time it's going to be standard error of the statistic. Okay? They're going to put standard deviation, but you should know that most of the time when you do this, you're going to write standard error, SE, right? Not SD. Okay? So this is the slope, 16.2809. Now this problem actually doesn't require you to put that. The question says to compute the margin of error. Where is the margin of error? David knows. Where's the margin of error? After the plus or minus. So if I compute these like values multiplied together, I'm done. That's it. So I need to find the critical value and I need to find the standard error. The easiest one to find right now is the standard error. Go back to the table. You don't have to flip over if you don't want to, but I have it right here. Right? Remember, where am I looking? The top. I mean, it is at the top, but like I'm looking at the speed row, right? Speed. Here's the slope. You'll notice this number next to it is underneath something called SE coefficient. This is the standard error of the slope of that statistic. So like, don't make it harder than it needs to be. Copy that down. 0.8192 is what I'm writing where it says standard error of the statistic. 0.8192? Was it?
Oh, that's a parenthesis.
Yeah, it's a parentheses. 0.8192. Is that a bad parentheses? Let me try again. Is that better? It feels like that's the same, but that's okay. All right. What am I going to put for the critical value? All right, let me put my plus or minus. If you haven't noticed, yesterday and today, we went back to what model? The T model. The T model. So that means, what is my critical value going to be? I needed degrees of freedom. T what? T what? What? T star. And how many degrees of freedom do we have? Not actually that much.
0.
Careful. How many data points did John plot?
7.
Didn't he plot 7? Weren't there 7? It said 7, right? And then, so that means it's 5. You subtract 2. Subtract 2 from that.
It's right here.
Oh my gosh! It does. In the output.
Oh, wait, I thought it was 6.
It's degrees of freedom. Let's see how we're doing for the residual. So we're doing the difference. But if you have any issues with that, right, you can do it yourself. Okay, so I draw a quick little curve here to the side. What level of confidence? 98%. So how much is in each tail? 1%. So now we're finally ready to turn on the calculator. Are you able to like text like that? That's amazing. Wow. You do inverse T. I just said do. That was fun. I said do. You do inverse T. So turn it on. I'm going to lose some subscribers for that because I just laughed at myself when I said do. You know, I may be 37, but I'm really not. What? I'm so close to 300. So close. I know. 283. So close. Oh, I can't technically get any money because I'm using my Christ Ray Jesuit email. Like I could change it, yes, but like because I'm using like a not for profit like organization email, I can't actually make money. It's okay. I just want to blow up, right? I don't need to make money.
Sure.
Right?
Yeah.
The next is amazing.
He's staying humble right
Who's-
now. So later, he's staying humble. When he gets
I had the same thought. Second bars.
Second one.
Second bars. Inverse T, which is number 4. The area I'm typing in is 0.01. We said the degrees of freedom was 5. Hit paste. Remember, this is not the answer. This is, nope, T star. This is the critical value, 3.365.
Why did he give it to you negative?
So I found this one, right? I just ignore the negative. If you really want to find the positive, like if that's something that it bothers you, then you could have typed in
0.99.
correct. So 0.99, because that'd be 1% to the right. So it should be the same, just positive. It doesn't matter. I just ignore it, right? I just ignore it. Now multiply 3.365. Notice, am I using the rounded one when I find the answer? No, right? So try to use the one that's not rounded. Times 0.8192. Oh, David just wanted to see if I could get a positive, and I did. You don't have to. Just ignore the negative. The margin of error is 2.757. So this
2.797.
757.
757.
No, because margin of error is after the plus or minus. So you're essentially saying, I expect the slope to be 16.2809, but if I'm saying I'm 98% confident, I'm saying I'm confident it's going to be, no more than what? 19, a little over 19, and no less than 13 and a half-ish, right? That's what I expect it to be, like 13 and a half to about 19. So if like John told me like another set of data, and I did this again, and I got a mean for the slope, sorry, there's people on the roof, it really freaked me out. If I got a slope that was not in between there, then I would be like, oh, something interesting is going on. If I got a slope of like 9.
If you were to do like a 99.99% confidence
Okay,
interval,
sure.
the thing would just get bigger, like the interval.
So if you want to be more confident, you have to make the interval wider. If you want to be like more accurate, you have to be less confident. Like there's always a give and take.
Yeah, I was gonna say was like that.
So like the most confident you'll be is great. You'll be more confident, but your intervals are super wide.
What's it to be 100% confident? It has to be like all the numbers.
I'm never going to be 100% confident, right? Has it already happened?
No. But then